What's going on, guys? Want to do another quick shop tip video for you with a little bit of a disclaimer before I get started, and that being that I'm not sure how helpful or universal this might be for some of you, depending on what kind of access you have to what I'm about to show you. That said, I figure if anything, it'll at least get the wheels turning in your own minds and maybe give you some ideas for some similar applications with something maybe that you do have access to. But what I have here in front of me are some rollers out of a large industrial roller bearing, and more specifically these came out of a large conveyor wheel at one of the many chain link conveyors out at the steel mill that I work at. And what happens is that these conveyors have hundreds of wheels on them that are fairly large, and each of them contain dozens of these little rollers on either side of them. And what typically ends up happening is that if these wheels get caught on anything, or if they stop turning for whatever reason or wear out, is that they end up breaking and dumping all these little rollers out all over the floor. So while I was underneath the conveyor one day doing an inspection, I figured I'd pick up a handful of them, take them home and see if I couldn't actually use them for parallels or standoffs in my machine vise on my milling machine. And the idea behind that was that these are originally machined to very precise tolerances in order to work properly, so they're all pretty much identical, at least when they start out, in both diameter and length. And the only thing that can change that obviously is the wear rate on the bearings, but being that these are hardened bearing steel, the wear rate on these are extremely slow, if anything at all, depending on how quickly these bearings come apart. For instance, like I say, if they get caught on something or the wheel shears off, you'll have several of these pretty much brand new rollers with hardly any wear whatsoever on them. And you can kind of see just a little bit of wear, if I can focus in on that, on the ends there. But it's still pretty relatively flat. These are in an oil bath or a grease bath while they're inside the bearing. So again, the wear rate is very slow, and if anything, they'll retain their tolerances at least enough that we can either hand lap them to exactly what we need them, or at least be close enough for the type of work that I'm going to be doing on my milling machine. And just to give you a quick example, using this cheap set of calipers here. Got about 494 on a diameter. Again, 494. 494, so just under half an inch. Try to get these on straight. I'll say 967 for a length, and obviously these are going to vary. So 966. Try this one again. Yeah, 965 and a half, 966. Obviously these are going to vary depending on the size of the bearing that they came out of. Helps to get it on straight. 967, and if my calipers were actually in line, I could probably get it to the same 966 as the other. But the point being, they're very close in tolerance to each other, even after being used inside the bearing. You're going to typically find, at least in my experience, between a half thousandth and a thousandth at the most, if not even tighter than that. So they'll certainly serve the purpose for what I intend to use them for, which is standoffs or parallels. And I'm not going to say that they're better than parallels. Obviously parallels are designed with a purpose behind them, and definitely work very well. But in this case, these were free, and a good set of parallels, depending on how precise you want them or how many sizes and what lengths and widths and whatnot, can be very expensive. So again, for my purposes, these are close enough and useful enough that I can save quite a bit of money and still get the job done as far as holding my workpiece off the bottom of my vise. And just to give you a quick example of use, you could certainly stand them up, either one on either end or two on either end, maybe one in each corner, depending on how wide your piece is. Stand it up off your vise like that. or you can even use the diameter, lay them over, and you're still parallel as far as the bottom of the vise is concerned. Now obviously you get a little bit of roll it back and forth, clamping your vise down will take care of that. So just a quick idea for you guys. Again, we're looking for something that's essentially identical as far as width or length, to keep the piece elevated the same distance from either side, which is essentially the idea behind a set of parallels. Now obviously you can expand this to other machined parts that are closely toleranced, even other rollers, other bearings, even just a regular skateboard bearing. If you want to stand the race on their sides, they're typically fairly close in tolerance, or even the diameter of that bearing. So again, that's just an idea, guys, and it doesn't necessarily have to be strictly bearings that we're using here, but one main advantage again is that these are hardened steel. They do wear very slowly, if at all. And obviously because of that, I think it goes without saying, same as with parallels, you want to keep your cutters and your tool bits off of them, as you will destroy both the bit and probably mar these up a little bit as well. So that's it, guys. Hopefully it gave you some ideas. Maybe if you have access to similar pieces like this, you can put it to use as well. Any other comments, suggestions, ideas from you guys, I'd certainly love to hear them in the comments below. And as always, thanks for watching.